So let us define a line graph. Okay, so if G is a simple graph, then we can construct the line graph of G as follows. Look here. So this is the graph G, and we can construct the line graph of this, right? So in this graph I have 7 edges. So while constructing its line graph, the edges will become the vertices. And look here, the edge E1 is incident with E2 and E4, right? So here the vertex E1 is adjacent to E2 and E4. So like that we can construct the line graph of G, and these are the few results on the line graph. The line graph of a connected graph is always connected, and if the line graph is connected, in line graph of some particular graph is connected, then the graph is also connected. Okay, so if H is a subgraph of G, then the line graph of H is a subgraph of line graph of G. If we have an edge E, that is U into V, U is the starting vertex, V is the terminus vertex, then we all know how to calculate the degree of this U, the vertex U and the vertex V, right? The number of edges incident with U and the number of edges incident with V. So like that we can calculate the degree of U and V. So in the line graph of G, the edge E will become the vertex, and the degree of that will be degree of U in G plus degree of V in G minus 2. So that is the formula. Okay, so let us prove a result on the line graph. The line graph of a simple graph G is path if and only if G is a path. So we all know what is a path. So a path is a walk where all the vertices are distinct, right? Fine. So here suppose G is a path Pn on n vertices. Now I want to show that the line graph of that is also a path. Okay, so if G is a path on n vertices, so like this, then here I have Pn, it's a path. Okay, right? I can see n minus 1 number of edges here. So while constructing the line graph of this path, so these n minus 1 edges will become the vertices here. Okay, so since we have a path on n minus 1 vertices, definitely here I can see n minus 2 number of edges. So the line graph of that is also a path Pn minus 1, so with n minus 1 vertices. Okay, so conversely, suppose G be a simple graph such that the line graph of that is a path. We need to show that G is a path. So once the line graph of G is a path, then we can say that then no vertex of G can have degree greater than 2. This is obvious. The reason is, if G has a vertex V of degree greater than 2, then the edges incident to V would form a complete subgraph L of G with at least 3 vertices. Okay, so that is not possible here. Okay, so since L of G is a path, this cannot be possible. So we should have no vertex of G can have a degree greater than 2. So what happens if G have a vertex of degree greater than 2? Then that will contradict to the fact that L of G is a path. Okay, so that's why no vertex of G can have degree greater than 2. So hence G must be either a cycle or a path. Okay, so since L of G is a path and the line graph of a cycle is cycle, we can say that G cannot be a cycle. Okay, so thus G must be a path.